Machine learning or the combination of these areas, then you'll get advantage because of this VLSI plus either signal processing, communication, or machine learning. So because of this three areas overlap, you may get good opportunities. This is regarding the first question. The second question is like master slave flip-flop. So I'll just explain this. So in master slave flip-flop will be having one master flip-flop, which is normally JK flip-flop. There are some intermediate outputs given complement. This is JK. This is master. And this will be applied to SR flip-flop. Post clock is complement of this clock. Here we are going to apply the clock directly. Here this is clock bar to inverter. Then the final output is taken here. Final output to complement. The third input. So we will third input of this one is connected. You see the circuit diagram of master slave flip-flop. So over a complete period of this clock cycle, the output changes only once. We take the clock, relay transfer from 0 to 1, remains in 1, 1 to 0, then again 0 to 1. So if we start at this point, till this point, one clock period. So the problem with the conventional JK flip-flop is the output changes several times over a clock period. So at the end of clock period, we don't know the output. Output is uncertain. Here if I start with J is equal to 1, K is equal to 1, and if the previous state is 0, then to get this state 0, 1, this is basically SR. We take the truth table of SR flip-flop, SR QM plus 1. 0, 0, it remains in the previous state. 0, 1, regardless of the previous state, 0. 1, 0, regardless of previous state, 1. 1, 1 is not allowed. So to get output is equal to Q is equal to 0. So output is equal to 0. Input should be 0, 1. So this should be 0. This should be 1. Then only you will get output as 0, 1. And J is equal to 1, K is equal to 1. Clock is equal to 1 at this point. This is 5 volts. This is 0 volts. Then this clock will be 0 because clock bar. So the three inputs of the first NAND gate are, this is 1. So this is 1. Three inputs are 1 is 0. And this one is 0, 1, 1. This is 1. If one input is 0, this is sufficient to say that output is 1. So this 1, 1 becomes 0, 0, 0 becomes 1. These are the stable states. So throughout this, when clock is equal to 1, clock is equal to 1 throughout this period, output changes, the intermediate output changes from 0 to 1. Previously it was 0, now it has been changed to 1. Then what about the final output? The clock is disabled. When clock is 0, SR flip-flop remains in the previous state. So this truth table is valid only when clock is equal to 1. If clock is equal to 0, regardless of the previous state, flip-flop remains in the previous state. Remains in the previous state. So previous state is 0, 1, so it remains same. So this will happen as long as the clock is equal to 1. This is clock is equal to 1. The entire portion of this is clock is equal to 1. Here this is changing from clock is equal to 1 to 0. This is exactly 0 volt. This is 5 volts. So 0 volt is 0 logic 0 and 5 volts is logic 1 ideally, but there is a range of voltages. Normally in case of TTL, 0 to 0.2 volts is taken as logic 0. Similarly, some 3.8 volts to 5 volts will be taken as logic 1. Here, whenever it reaches a value which is slightly less than 0.2 volts, so here this becomes logic 0. Here this is logic 1, and here also up to 3.8 volts logic 1. In between some undetermined state is there. Whenever it reaches a value which is less than logic 0, then what happens? Clock will become 0, this becomes 0, and whereas this clock bar becomes 1. So at that time, what are the inputs? This is 1, 0. 1, 0 means for 1, 0, output is 1. So Q becomes at this point. So at this point, when this voltage is point less than 0.2 volts, this Q becomes 1. So here we started with Q is equal to 0. See the point where Q is equal to 1. And you see the portion where it remains in the 0. Again, it will goes to 1. The voltage which is slightly greater than 3.8 volts. So during this portion, master is disabled and slave is enabled. And for slave, these inputs are 1, 0, output remains in the 1 state only. Whereas whenever it reaches a value which is slightly greater than this one, clock becomes 1. So clock bar is equal to 0. So this slave remains in the previous state. So till this point, starting from this point to this point, at this end Q is equal to 1, but there is only one change from here to here. That change occurs only at this point. That is a negative edge. That is why the this master slave flip-flop is called as negative edge triggered flip-flop. So the intermediate output will changes when the clock is equal to 1, and when clock is equal to 0, the intermediate output will be applied to the SR flip-flop and the final output will changes. This is one of the doubts. Another is regarding the transmission gates. So transmission gate truth table is basically here we'll be having data input. In each type MOSFET, another type MOSFET. There is the output, data, we control, so N control is not complement of the P control. It's a different control signal. So for this P channel MOSFET, N channel MOSFET, this P control, N control. We take it to table. The different values of the data. Data can be 0, 1, don't care, or high impedance state. So if both are 0, 0, P channel device will be on if VGS is, we have this rule, P channel device is on if VGS is negative. So N channel will be on if VGS is positive, and the other channel will be off if VGS is 0. So for 0, 0, this is because P channel, this will be on, this will be off. There is a short circuit path. If I take this data, here this is off means ideally open circuit. This is on means ideally closed circuit. This is output, this is data in. So through this path, whatever the data will be transferred to the. So data is 0 means 0, 1 means 1, don't care means don't care, Z is Z. So if 1 is 0, another is 1. P control is 0, so this will be off. And 0, this is P control, this is N control. So this will be off. N control is 1 means P control is 0 means this is on. Plus P channel, P control, and N channel control means this is also on. Both are this, both will short circuit path. So output is equal to this is so high. Next step. 1, 0 means both will be off. P control is 1 means this will be off. N control is 0 means this is also off. Both will be off means both will be open circuit. Also open circuit. So there is no path from input to output. So it remains okay, X Z. Both are 1 means again this same situation. 1 will be on, 1 will be off. Get image X Z. So if both are zeros, then both are zeros. N channel is 0 means this will be off. Each channel is 0 means on. So one of this one is on. So output will be just there is a short circuit path from input to the output. So in case of 0, 1, both will be off. In case of 1, 0, one of this one will be on. One also one of this one will be on. So between these two, these are the possibilities. Both can be on and input to output. So in this case, there is short circuit path between the input to output, but there is a parallel path. So in the other case, one is off, another is on. In this case also, through this path, input will transfer to the output. So only the case where both will be off, open circuited, then there is no path from input to output. Okay. So for all the combination, so now this will happen. So as a result of that, we'll get the outputs accordingly. So the next question is, this already have answered. First question and the fourth question are almost the same. So if you want, you can work on the front end or back end. That is up to your interest. And the opportunities wise, I think there are equal opportunities for both the front end as well as back end. Yeah, if you have any other questions, please raise your questions. I'll check that. I'll check with my TS. Assignment number 6, question number 4. I'll check the answer. Assignment 6 and question number 4. Both answers are correct, then we will do according to that the evaluation. So inverter will be having only one input and one output only. But in the transmission gate, in addition to the input output, there are control signals. So we can implement a control inverter, but not the direct inverter. If you have any queries, please ask. Yeah, it is drain source gate. This is it is this is a drain source and gate. Now it is unmuted. If you have any queries, please ask. If you don't have any queries further, we'll close the session. Thank you.